Where's digestion begin? No, it begins in the pan. Heat actually breaks down material in the pan, but we're not talking about the pan, we're talking about in the body. Digestion begins where? In the mouth. Digestion begins in the mouth. In the mouth, we have two different processes that take place, both mechanical and chemical digestion. You will notice that most of what I say tonight is summarized on this handout. If you don't have the handout, that's okay. Look up there. What's up there, you don't need to write, because you have that. You can just write little notes around it. The mechanical digestion in the mouth occurs because we have what parts in there? Oh yeah, these hard things called teeth. And we have a jaw, and we have muscles. You're right. We have muscles that allow us to move that. You know, your great-great-grandpa that has no teeth, he just gums it, and that's how you remember Gomphosis joint. So that's mastication. You need the teeth, you need the jaw, you need the muscles. Is your tongue important for that? What's it do? It does. It's so subconscious, but our tongue helps to center our food over our teeth when we chew. Imagine chewing, you know, without a tongue or without cheeks. Oh my goodness, it would fall right out. But realistically, we use our cheeks to push and pull and put food where it's supposed to be too. That's why every once in a while you bite your cheek or you bite your lip. Or when you get a snaggle tooth, like, you know, I got this one little tooth that's every year it sticks out just a little bit further and a little bit further. I don't know. That's what happens. Chemical digestion. Due to what glands? Salivary. Salvatore Dali, you know that's a different guy. Yeah. We have, in the mouth, there are only 2 digestive enzymes produced. But that's probably 2 more than you might have thought. Or maybe 1 more than you might have thought. Do you remember in junior high when you put the cracker in your mouth and let it dissolve? Anybody remember that? Or maybe it was high school, or maybe it was lunch. I don't know. Whatever it was. You put a cracker in the mouth, and if you let it sit for about 30 seconds to a minute, all of a sudden that cracker gets sweet. Most of us chew it up and swallow it way before that. Okay? But if you let it sit, it gets sweet. Why does it get sweet? It's chemically broken down from polysaccharides into disaccharides. See, disaccharides are like table sugar, sucrose. How many people remember a polysaccharide, a disaccharide, and a monosaccharide? I know, you're going, I know that name. What's it mean? I don't know. Monosaccharide is like glucose, that's one. Disaccharide is a double sugar. They still taste sweet. They're very small, but they have to be broken down to get absorbed. Only glucose, only the small ones go right in. So polys, huge ones, we break down into dis. Dis we break down into monos. Monos get absorbed. I know that I'm going fast because I was prepared, and you have this other sheet. Whether you have it with you or not, it's called organic macromolecules. Look at that. Do what? Right on. Did you bring them? It wasn't there. Oh, it's in the lab thing, I think. Yeah. Oh, it's in the lab. If you look, it's in the digestive anatomy lab. No, I'm not. I know I turned it on in my other classes because other people had them, but maybe it wasn't on. Actually, I thought I turned it on earlier, but it's probably in lab, and you probably weren't looking back in the lab folder you already went to be honest. So anyway, you'll be able to print this up later. It describes monosaccharides, disaccharides, and polysaccharides again. Okay? But where we're at, the chemical I'm talking about is called amylase. Ace means enzyme. Amyl? I don't know. It means a polysaccharide. It means a big carbohydrate. See, this breaks down big ones. And by the way, if you look lower, down here, where you see amylase, it does the same thing no matter where it's secreted. Okay? So I have a deeper definition lower. There is lipase produced in your mouth by the salivary gland. What do you think it breaks down? good. That is not lipase. It is not there to break down your lips. It is lipase. It is there to break down fats. So let me ask you, kids, and not so kids, how long do you chew your food? What do you tell Randall? Boy, chew your food. You know, it starts out nowadays, I don't know if you know this or not, but in elementary school they no longer get recess. They get lunch. I remember when my daughter started school, I was shocked. They don't get recess, they get lunch, and they have to sit at the table for 10 to 15 minutes, and then they're told the rest of lunch you can play, but you have to sit for that long. So what do? In 5 minutes, they wolf everything down, and they're waiting. And the teacher finally goes, okay, and they're out the door because they want to go play. It gets no better. You get to high school, you get 40 minutes for lunch, you got to go to your locker, you got to go to your car, you got to meet up with your friends, you got to drive somewhere, you got to wait in line with 100 other people, and then you got to do the whole process in reverse and eat and get back to class on time, unless you're one of those people that doesn't go back to class on time. Okay? The point of the matter is, in our early years now, when we're away from home, commonly school systems are teaching us to eat fast, to wolf it down. You can't chew well if you're eating a meal in 5 minutes, right? You're just going, three bites, one piece of pizza, it's gone. One bite? One bite. One bite. So let me ask you, how well do the amylase and lipase get to interact with the molecules in that pizza while it's in your mouth? Not much. So guess what? The rest of your digestive tract that does not have teeth now has to use excessive amounts of chemicals to break down what your mouth was supposed to do. It can handle it, but years and years of doing that makes it rough on the rest of your digestive tract. You really should use those teeth. You got them for a reason. Okay? We have these sphincters we know about. The sphincter guarding the entrance to the mouth is called the blank orbicularis oris. And what kind of muscle is it? Skeletal. Good. Oh, skeletal. Skeletal. I flash back to college. My pathology teacher was British, so they say things different. They say skeletal. It's not. It's the British way. Okay. And capillaries. Exactly. But we don't. Okay. Then food, which is now called a bolus, moves to the back of our mouth and swallowing is initiated. Okay? It passes through the pharynx, which we'll talk about later, into the esophagus, and it travels down. What is the primary function of the esophagus? But there's a fancy word for to move it down. Peristalsis. Peristalsis. That means a wave-like contraction. The food is now called a bolus. The mucus in your saliva helps to stick it together, and it's a little ball of food. Swallowing is a reflex, and it is generated when food gets to the back. Do you know why you have the uvula hanging down? It's a little sensory receptor right there. It's not to look cool. So if food comes back there, it hits that. It lets you know, here it comes. So you have two choices. You can swallow or you can kind of cough, right, and get it out. But the whole point is that is sensory. It helps you to know where the food is. Because you don't want it getting too far without your awareness, because then you would choke on it. Okay? The esophagus is divided in three parts, a top, a middle, and a bottom. Look on the sheet and tell me what kind of muscle is at the top. Skeletal, you have some control over that. It blends in the middle, and then at the bottom it is smooth muscle. You do not have conscious control over your smooth muscle. Are you seeing any enzymes produced by the esophagus? No. How long does it take food to pass through the esophagus? Longer than you think. 5 to 8 seconds is typical. Liquids pass quicker. It takes 5 to 8 seconds for solids, though. Now the bad news. Oh, that's interesting. Does food ever move in reverse? Oh, yes, Jerry? What do you call it when food moves in reverse? I hear vomiting, regurgitation, throwing up, puking, hurl, blowing chunks. I say worshiping at the porcelain altar. Yeah. Any others? Ralphing? Tossing cookies? Did we said that one, I think. Did we say vomiting, though? Yeah, that was the first one? Okay. We said regurg. So there you have a whole collective group of terms, and not a one of you said this. Emesis. An emetic is a drug that induces vomiting. Emesis is the process of reverse peristalsis through the esophagus. Oh, my. What was mastication? Chewing. What's a bolus? Where? Good. At the back of your mouth, in your esophagus. Do you know what that food's called when it hits the stomach? Chyme. Very good. That is CH, but it sounds like a K. All right, we have two sphincters associated with the esophagus. Let's look at a picture of this upper one, because you probably have not seen this yet. Hey, what region is this? That is the larynx. The pharynx is here, right? Naso, oro, laryngo. This is forward. This is the voice box. This is the larynx. This is the trachea. This is the esophagus. And what is this narrowing right here? That is your upper esophageal sphincter. Watch this. It's closed. Here's the food, the bolus. That looks like some gross food. Look at it passing down. That looks like a yellow tongue. Okay. It's a pancreas. Look at it opening up here. The sphincter opens. Oh, my goodness. And then the food passes down and it closes right there. Pretty neat stuff, don't you think? Eructation is burping. Deglutition is swallowing. Mastication is chewing. Borborygmus are bowel sounds. And Meganblas is an enlarged gastric air bubble. Josh Radtech should know that. Enlarged gastric air bubble. In the fundus of the stomach, on an x-ray, you see a black space, a black air space. Because there's air there, and on x-ray, air densities appear black. Oh, no, that's normal. To have air there is normal, okay? A Meganblas is when it's enlarged, but that doesn't mean they would have any pain either. So those are some of the fun little words. We talked about emetics, vomiting, all the fun names for that, a bolus, chyme. Let's go back to our sheet. Now we're going to hit the stomach. Or as we like to say, the stomach. Why do we say stomach? Because we're being funny and trying to help you spell it right. Here's some peristalsis, the bolus. It hits here. This is the stomach. We know that right here, where the esophagus and the stomach join, is a sphincter called lower esophageal or cardiac or gastroesophageal. I don't care what name you use. And since it's right there, what kind of muscle is it? Smooth. It's smooth muscle. This is the fundus. Here's the body. Here's the pyloric region. You already know that. The pyloric sphincter is right down here. So here's our other two sphincters. Within the stomach, we have a mucus blanket that is produced by some cells there. It's actually a blanket of mucus. Doesn't that sound lovely? Jerry, you ever seen that come up? Probably so. Yeah. Why do you have it? Exactly. So the acid doesn't eat through the wall of the stomach. The stomach is a very acidic environment. The pH can get down to as low as 1.4 at times. That's crazy low. But it's made to do that because the mucus blanket protects it. Chyme, we know what chyme is. We already mentioned that. 2 major cells in the gastric glands that we kind of saw in the lab down in the pit of the gland. We know the parietal cells look pink and puffy under a microscope, but we also need to know what they do. Parietal cells make hydrochloric acid. Okay? They make the stomach acid. The other cells down there are called chief cells. And the chief cells make a digestive enzyme known as pepsinogen. Pepsinogen would be secreted in what form? Inactive. How do you know that? Ogen. See, you're starting to connect the dots already. There's all these little connectors in AMP. The active form would be called pepsin. Do you know what activates it? Hydrochloric acid. That comes from what cells? The parietal cells. Parietal cells. So how do you keep this straight? Here's how you keep it straight. For some things, like the macrophages reside in the medulla, we have M going with M. But here we have the P not going with the P. The parietal cells do not make the chemical from here that starts with the P. The parietal cells make the other stuff, hydrochloric acid and a chemical called intrinsic factor. The chief cells make the one that begins with a P. They make pepsinogen. All right. Okay, what is intrinsic factor? Intrinsic factor is a chemical also produced by the lining of the stomach, the parietal cells, and that is the chemical that allows us to absorb vitamin B12 in the stomach. Is B12 important? Name something it's important for. Okay, if you say energy, you're right, but I need you to take it further because this is AMP2. What is it about B12 that gives us energy that we talked about in Chapter 17? Blood. Close. B12 is necessary for red blood cell production. Nice, Tiffany. So what's all this bad stuff down at the bottom? Ulcers. Oh my. Tell me about some of that stuff. What do you know about ulcers? What do you know about GERD? What is GERD right here? GERD is acid reflux. Gastroesophageal reflux disease. GERD. Well, write it in. Here you go. GERD. Gastroesophageal reflux disease. We know what reflux means. What's it mean? Going backwards. Right? See, this is the significant form of heartburn, chronic heartburn. Gastroesophageal reflux disease, also called acid reflux, leading to heartburn. By the way, that is not a problem with too much acid, because a normal stomach with good healthy amounts of acid that take your pH all the way to 2 or 1.4 does not yield any heartburn. You get heartburn when this sphincter is not staying closed and when the contents here tend to bubble up into there, especially when you lay down. All right? Common during pregnancy because you have so much extra weight right there with the little baby and all the excess that it pushes on it and pushes stuff up through there. You should know there's certain foods that irritate that sphincter, though. So what we're saying is heartburn is really a sphincter problem. It's not so much an acid problem as it is a sphincter problem. If it is an acid problem, if anything, it might be due to low acid, believe it or not. And we'll talk about that in just a second. Well, H. pylori is related to ulcers, and we're about to talk about that. Okay? All right. Got that one. Oh, also in the stomach, before I get too much into the diseases. What does pepsin do? Digest what? Proteins. Notice, only protein. Notice that's the only digestive enzyme we mentioned here. The amylase and the lipase that came down from the mouth, they get mixed up in there and they get neutralized. They get broken down. They're enzymes. They get broken down. Oh, wow. So within a few minutes, they're no longer working. So in the stomach, it's protein digestion. The stomach is not your main digestive organ. It is the beginning of protein digestion. You're right, the duodenum is the main digestive organ. But what else happens here? We do actually start to absorb a little bit through the stomach. You absorb water. You absorb salt. You absorb aspirin. And you absorb aspirin, and you also can absorb alcohol. Those are the main things that you absorb through your stomach. This is why it does not take long to become inebriated. It does not have to pass all the way through the stomach and go into the small intestine and go to the duodenum. What's absorbed through the stomach? Water, salt, aspirin, and alcohol. Cool. So now let's talk about ulcers. They found out a few years back that ulcers are linked to a bacteria called H. pylori, or Helicobacter pylori. A significant percentage of people that have ulcers have excessive overgrowth of this bacteria in the stomach. So if you have a bacterial infection, what do you treat it with? Antibiotic. And it helps. Something we need to keep in mind, though. One of the jobs of the stomach acid is to kill bacteria. Wow. Let's think about that. We have our respiratory passageways and our cilia that constantly push up to the back of the mouth, and we swallow it. Comes down, and we swallow it. Goes up from our trachea, goes up, and it goes back, and then we swallow it down. Why? Because we have acid that will denature the bacteria. We have digestive enzymes that will break down protein. Well, veterinarians knew 50 years ago, 60 years ago now, that pigs with ulcers had infections from Helicobacter pylori. It took 40 years for medicine to figure out that it was similar in people. How crazy is that? Then there's something else that you want to understand or think about. Stress. You saw it at the top. Stress stimulates what nervous system? The sympathetic nervous system. Well, when you're under stress, what does it do to your digestive tract? Shuts it down. So what does that do to acid production? Lowers it. It decreases it. So what happens if you're not making enough acid in the stomach? You can't kill off the bacteria, so it can overgrow, and it can lead to ulcers. For years and years and years, they said that ulcers were caused by stress. They found the bacterial infection and started backing off from the stress. Hey, it's related. Stress lowers your acid levels. It shuts down your digestive tract. You can't kill off the bacteria. The infection proliferates. So you can treat ulcers with antibiotics, and it can work. But if you don't manage that person's stress, in the future it can come back. They can get another infection with H. pylori that grows and builds and causes ulcers again later on. So it is still linked to stress. So then we get to the magical digestive organ that begins with a D that people say in so many different ways. How do you pronounce this word? Duodenum? Duodenum? What's the other way? There's a third way. All right. This is your primary digestive organ. It comes right after the stomach. It is around 10 inches to a foot long, and it is C-shaped. How do we know? Because we've seen pretend pictures, and they're always right. No, 10 to 12, usually. Look right here. See, it's shaped like this, like a C. For Cooper. Right there it is. Right there. Look, right here where it bends the other way, it becomes the jejunum. Back to this little duo right here. What are these folds called? Yeah, I hate this book. Circular folds. Those are plicae circulares. They have just made it, easier in the lab book. I accept that, though, because the book has it. Notice something I want to point out. This main digestive organ here, it is very powerful itself, but also, look at this duct from the pancreas. It opens right here. And look at this duct coming down from both the gallbladder and the liver. It meets the pancreatic duct. It's called the bile duct. Pancreatic duct, really the main pancreatic duct. They open together right here, and there is a little baby sphincter there. This is not one of our major sphincters. This is a baby sphincter that guards the opening. Do you know what it's called? Sphincter of Oddi. Wait, don't write it. It's right at the bottom, the last thing on your sheet. If you have the new sheet. Okay, write it in. Poor class. You got the old sheet. I don't. Not one bit. I'm not going to argue with you. Sphincter right here. Look. Sphincter of Oddi. What organ is it located in? The duodenum. 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 What two ducts meet and come through that as one? The bile duct and the main pancreatic duct. Is that sphincter kind of important? Tell me, yes, why it's so important. Yes, ma'am. Because they, meaning the gallbladder, liver, and pancreas, dump their secretions into this organ where they can digest food or do whatever they need to do. All right? So one of the reasons this is the main digestive organ is because it gets a lot of help added to it. Right there. Very, very important. Now notice, as we do this, we will do pancreas and gallbladder and barely even mention liver. Now, I'll go through liver again later, kind of like we saw it in the lab portion. Right, so what is produced by the duodenum? Mucus. Why? Stomach spitting chyme in here little by little, and it's very acidic. We want to protect this organ that is not made to produce acid on its own. Then we have, so mucus is not a digestive enzyme, correct? It is just mucus. It is just there to be protective, to coat. In the duodenum, it's not as thick as it is in the stomach. It's not, we wouldn't call it a mucus blanket, which sounds so lovely. There are also amylase and lipase. Want to tell me what amylase breaks down? Which carbs? Big ones into double ones, right? Not quite the babies. Polys into dis. Lipase digests fat, breaks down fat. Peptidase, peptide, breaks down proteins. Yes, I skipped some. I did that for a reason. So notice, carbs, fats, and proteins, right? So now we've broken down a lot of carbs from polys into dis, but we still can't get them into the blood because they're too big. So they need to be broken down further from disaccharides into monos, as are listed on this sheet. Notice the three disaccharides from AMP1 are called sucrose, maltose, and lactose. Lactose is commonly found in milk. Sucrose is the kind of sugar that you sprinkle on your Frosted Flakes. Raise your hand if you add sugar to Frosted Flakes. There are people in every class. Wow, how many in here? I saw 7 hands. Look, sitting together. Sitting together. Wait, right here. Where were you? Sitting together, all alone. But you're sitting by someone in your class that does that, I guarantee you. Who would it be? I don't know. Laura? It's got to be. Yeah, it's got to be Laura. All right. Maltose, malt sugar. You go order a malt at Sonic, they put some maltose in it. That's why it tastes different than a shake. Okay. Those get broken down into their respective monos by the enzyme that would sound almost the same but have an A there. Sucrase breaks down sucrose. Maltase breaks down maltose. And lactase breaks down lactose. Let's see it on this handout. So what is lactose intolerant? It is when you're not producing enough lactose. It starts off usually where you're just producing a little less, a little less, a little less, and pretty soon you're not producing enough to digest the milk very well. What does that lead to? Bloating and excessive borborygmi, multiple vowel sounds, and running very quickly to Mr. Porcelain. Okay? And usually it does not come out the top, just so you know. Yeah, actually it's best if it goes the way it's supposed to go, because when you throw up, not only do you destroy the enamel of your teeth, you burn your esophagus, which can lead to esophageal cancer and erodes the esophagus. It can even get on your vocal cords, damage your voice, cause tumors to grow on your vocal cords. It can move into your trachea, move down into your lungs. That's called aspiration. It can kill you. You can get an infection and die from that. So therefore, we're glad that lactose intolerance typically moves it the other way. Okay? So why are people lactose intolerant? So why are people lactose intolerant? Why are they not producing the enzyme? Okay, genetics, good. People of different races are more lactose intolerant than people of other races. What else? I'm looking at a bigger picture though. Why are we lactose intolerant? Because milk is made for babies. I don't know, Jerry. When's the last time you drank some human milk? It's been a long time. Yeah, I thought he was too. So, I don't know. Raise your hand if you've had human milk in the last 10 years and you're not afraid to say. One person. Oh, you're kidding? Oh. Oh, you know, sometimes if you've had the baby, some people taste it, see what it's like. You ever heard of a La Leche League? Where they bottle their own milk and they share it? They're even pasteurizing human milk now. That grosses so many people out. But it's so funny. We gross out about human milk, but my goodness, who would crawl under a cow and take it straight from the tap? You know? Nobody would. Something to consider. Cow milk is made for cows. It has growth factors for cows. How big are cows? Do we really want to get that big? I think people milk has growth factors for people. Wow. Animals in the animal kingdom, they don't drink milk as grown animals unless we give it to them. They don't drink it. It's not natural. So therefore, what happens in people as you get older, in a lot of people, less lactase is produced to break down the milk sugar. Why? Because biologically, people aren't made to break down that because they're not supposed to be getting it so much. But you know how we are. We can do whatever with whatever, so we can drink milk. And now we put milk in most of the foods that we make, right? My poor brother is lactose intolerant. I'll record this. Anybody? Okay? One of his favorite things to eat is macaroni and cheese. He prefers Kraft. How many of y'all like Kraft? How many like Velveeta? How many like homemade? All right. So, you know, who cares which one you like? The whole point is there's a lot of milk in that, and the worst day of his life just about was the day that he realized after 3 bites of that he had to run to the bathroom, and he had to stop eating it forever. It was pretty horrible. Hey, how long do you plan on staying married? Okay, meanwhile, back at the ranch, there's this other chemical called enterokinase. I'd be so glad you're not here tonight. Enterokinase, it's an enzyme. It is not a digestive enzyme. It is an activator. It is an activator of some pancreatic proteolytic enzymes. That means protein digesters. These right here. The main one is called trypsinogen. Enterokinase activates it. So how does that work? Watch this. Let's flip to our picture. The pancreas produces 3 major protein digesting enzymes. Trypsin, chymotrypsin, and carboxypeptidase. Those are on the sheet, and those are their active names. They are secreted into this organ in the inactive form. Tell me why. Say it different. If they were, not only do they not need to, they better not. If they were active, they would digest the pancreatic duct and the pancreas itself. So they're secreted inactive because they have to be inactive here. The brush border, the microvilli of the simple columnar cells in the duodenum produce enterokinase. It's in there. When the trypsinogen comes in, it cleaves off the ogen, so to speak, and turns it into trypsin. It activates it. And trypsin, in turn, activates the other 2. Here are their names again. Trypsin activates chymotrypsin and carboxypeptidase. They become active once they're in the duodenum. The activator is enterokinase. Look at its name. ACE tells you it's an enzyme. Entero tells you it's in the intestine. Kine. This is our 3rd time to have kine. Protein kinase, cytokine, and now this. Activator. That's all it means, is activator. Remember, a kinin is an activator. What part of the pancreas is the digestive portion? Pancreatic acini. What kind of cells is it made from? Cuboidal epithelium. Not necessarily simple, right? But cuboidal epithelial cells. Okay. Other enzymes produced by the pancreas include a brand of lipase and amylase. What's lipase breakdown? Fats. What's amylase breakdown? Not try. Good. Polys into dyes. Very good. Polysaccharides into disaccharides. And yet there's one more thing we haven't talked about. When you eat food that used to be living, there is DNA in there. So you eat DNA on a daily basis. If you eat plants, plants were alive, plants have a nucleus, plants have DNA and RNA. So therefore, whether you're an animal or a vegetable, you're getting some DNA in there. You're digesting it. What kind of chemical breaks down DNA? A nuclease. We're not breaking it down for energy so much as we are to recycle its parts and use them again. Okay? It is very ingenious. Additionally, the pancreas produces a bicarbonate-rich secretion. To do what? Buffer, neutralize the acid, to help protect the duodenal lining, just like, well, with the mucus. The mucus is there. The mucus isn't buffering. It's coating. And then the pancreatic juices buffer. They change the pH because different enzymes are made to work at different pHs. All right? Do you imagine that you want your stomach to dump all of its contents at one time into the duodenum? No, you want it to empty slowly. So go to the bottom and you see these hormones for digestion. There are a lot of them, but I just want to talk about 4 of them. I will make, hopefully, their names mean something to you and stick. You want to take a wild guess what produces gastrin? The stomach, the gastric region of the body. When food enters the stomach should become activated. It, of course, does this by just simply the presence of food and the stretching. That activates the gut. I don't know if you know, but your gut has more neurons in it than your spinal cord. Did you gather that? More neurons in your gut than you have in your spinal cord. That is insane. It has its own network. We saw the plexuses, the myenteric plexus, the submucosal plexus. In the lab part, you saw that. They spread through the digestive system. But it is an amazing amount of neurons. I say that so you know that the digestive tract can really regulate itself. You put food in there, food stretches it, it moves, it contracts, it pushes, it pulls, it does what it does, it starts to produce secretions. Additionally then, certain cells make hormones. These hormones usually don't travel as far as the kind of hormones we've talked about before. So gastrin just works upon the stomach, this brand of gastrin, and it activates the stomach. It causes it to contract more, to produce more secretions, because it's responding to the presence of food. Anybody happen to know what histamine as a hormone in the stomach does? Look what letter it starts with. Here's your memory device. H. What's an H? Plus. A hydrogen ion. What is a hydrogen ion? In a word, acid. It is acid. Where is acid produced? In the stomach. Take a wild guess what hormone leads to the production of acid. Histamine. Yeah, they call them proton pumps that make the histamine. That make the acid, hydrochloric acid, and they're responding to histamine. Do you think it's possible that taking a lot of antihistamines might affect this? Yes. Yes, it can. So gastrin and histamine, both in the stomach, both help digestion. Gastrin just gets it going. Histamine, hydrochloric acid, HCl, hydrogen ion. Let's skip the big one. Let's go to the little one. Secretin. Secretin has a deceptive name because what I want you to know about secretin is it's produced by the duodenum to slow the stomach. S for secretin, S for slow. H for histamine, H for hydrogen ion. G for gastrin, gastric stomach. Gets it going. Oh my, he's alliterative. Secretin does what? Slows the stomach. SSS. Gastrin gets it going. Secretin slows it. From the duodenum. And it acts upon the stomach and it slows it down. And then my favorite, save it for last. Go ahead and ask. You got it? All right. Cholecystokinin. Let's break down the word. Cyst, actually bladder. That means bladder. Guess what chole means? Gall. Gallbladder. Yeah, it has to do with bile. The gallbladder, kine, activator. You want to take a wild guess what cholecystokinin activates? It activates the gallbladder to contract and release bile into what organ? The duodenum through what sphincter? Odie. The little Odie. The little Odie that could. Look right here. Gallbladder, cystic duct, bile duct, sphincter of Odie. Right here, really, is the sphincter. This is the opening. It's called the hepatopancreatic ampulla, but I usually don't talk about it. I like the sphincter of Garfield's friend. All right. Sure, absolutely. What am I repeating? Watch this. Okay, activates the gallbladder to release bile. So the gallbladder contracts and squeezes. So it must have what kind of tissue in it? Smooth muscle. Good. It pushes it through the cystic duct into the bile duct, where it travels down and goes into the duodenum through having to pass through the sphincter of Oddi. Do you think that gallstones can block this passageway? Yes, and that's bad. By the way, my grandma had a gallstone that was the size of an oyster. Yeah, the surgeon that removed it told her it was the largest one that he's seen in 30 years. Crazy, huh? Yeah. My other grandma, both of my grandmas are missing their gallbladders, but my mom and dad both have them, so I'm hopeful. And my other grandma, hers was like powder. Or sand, I should say. Hers were little and tiny for the most part, and the others just huge, massive. Okay, look back here. Gastrin, histamine, cholecystokinin, secretin. If, I want this to make sense, if cholecystokinin causes this to pump, wouldn't it make sense that it causes it to pump out through here too? So name the other organ that it stimulates besides the gallbladder. The pancreas. See, it's very logical. I'm trying to keep this logical and make it make sense. And use the fact that you're in AMP2 and you know a lot of words now. A lot of words now. Even more words than before, even though you were an English major. It does. It causes the pancreas to release its secretions, and it causes the gallbladder to contract. What does the gallbladder do? Store and release bile. It also concentrates it a little bit. It does not make it, but it concentrates it. We'll talk about bile a little more later. And where's bile produced? In the liver. It goes to the gallbladder for storage. If you have your gallbladder taken out, your bile cannot be regulated as well. Over time, your body learns how to make up for that. But when people first have their gallbladder out, if they try to eat a fatty meal, it usually causes them a lot of problems. And over time, the body adapts to that. Okay? We'll talk more about liver later. What does bile do? The fancy word is emulsifies fats, meaning breaks it down into lots of droplets. What's the purpose of that? Okay, so here's the deal. Fat, like if we took a bunch of oil and poured it on the tabletop, the oil likes to stay together, right? If you have an enzyme called lipase that wants to break down the fat, it wants as much contact area with the fat as it can. So if we have one big pool, it can only touch the outside. If we disperse that into teeny tiny invisible droplets almost, then it can attack the fat from all angles and break it down more. That's what emulsification is. It separates fat into tiny droplets, literally thousands and thousands of tiny droplets that the lipase can now act upon. So emulsification is not digestion. It is separation or dispersion of the fat. Okay? And that is the first talk about digestion.